Hi everyone. Wishes for the day. We are from Technical Building Analyzer. We are here to help you for improvement of technical building maintenance work of smooth operation without any effect. Today topic is electrical structure of power supply to the building. The main objective of SLD is to provide a simplified visual representation of the electrical system's topology and connections. It helps in understanding the flow of electricity, identifying key components, and planning or troubleshooting electrical systems. Transformers work on the principle of Faraday's law of electromagnetic induction. When an alternating current, AC, passes through the primary input coil, it produces a varying magnetic field in the core. This changing magnetic field induces an alternating voltage in the secondary output coil, through electromagnetic induction. The ratio of the number of turns in the primary and secondary coils determines the voltage transformation between the input and output sides of the transformer. A step-up transformer is a type of transformer that increases the voltage level from the primary winding to the secondary winding. It accomplishes this voltage increase through electromagnetic induction. Step-down transformer, it decreases the voltage from the primary input side to the secondary output side. The secondary coil has fewer turns than the primary coil, resulting in a lower output voltage compared to the input voltage. An electrical single-line diagram, SLD, is a simplified illustration that represents an electrical system or network using single lines to show the connections and components within the system. It's a fundamental diagram used by electrical engineers, technicians, and designers to understand and plan electrical systems. The main distribution board, MDB, is a key component in an electrical system that serves as a central hub or point for distributing electrical power to various circuits within a building or facility. It's also known as the main panel, main breaker panel, or consumer unit in some regions. The MDB receives electrical power from the main supply source, such as the utility company or a generator, and contains multiple circuit breakers or fuses that control and protect the distribution of electricity to different areas or sections within the building. Incoming power connection, the main power supply enters the MDB. This can be from the grid, a generator, or another power source. These devices are installed in the MDB to protect each branch circuit. They can be in the form of air circuit breaker, ACB, mold case circuit breakers, MCCBs, or fuses, and they disconnect the circuit in case of overload, short circuit, or other electrical faults. The MDB distributes electrical power to various subsidiary distribution boards, subpanels, and circuits throughout the building or facility. MDBs include monitoring devices or meters to measure electricity consumption and provide information on power usage. They might also have switches or controls for shutting off power to specific areas during maintenance or emergencies. ACB stands for Air Circuit Breaker. It is a type of electrical protection device used in low and medium voltage systems to protect circuits from overcurrent, short circuits, and electrical faults. An ACB is designed to automatically disconnect the electrical circuit in case of overcurrent, overload, or short circuit conditions. It prevents damage to electrical equipment and wiring by interrupting the flow of current when an abnormal condition occurs. ACBs use air as an arc quenching medium. When a fault occurs, an arc is generated due to the flow of current. The ACB's mechanism swiftly extinguishes this arc using the surrounding air, ensuring a safe disconnection of the circuit. Current ratings, ACBs are available in various standard current ratings, typically ranging from a few hundred amperes to several thousand amperes. The rating specifies the maximum continuous current that the ACB can carry without tripping. A sub-main distribution board, SMDB, is a secondary distribution panel used in electrical systems to further distribute power from the main distribution board, MDB, to specific areas or sections within a building or facility. The purpose of an SMDB is to divide and control the electrical supply to different parts of a structure, such as floors, zones, or departments, by grouping circuits according to their functionalities or locations. It receives electrical power from the main distribution board, MDB, and further distributes it to specific areas or sections within a building. Similar to the MDB, an SMDB contains circuit breakers, fuses, or protective devices that control and safeguard the electrical circuits connected to it. These devices protect against overcurrent, short circuits, and electrical faults within their designated areas. A MCCB stands for Mold Case Circuit Breaker. It's a type of circuit breaker that offers protection against overcurrent, short circuits, and electrical faults in electrical systems. MCCBs are designed to protect electrical circuits and equipment from overloads and short circuits by automatically interrupting the flow of current when it exceeds a certain threshold. The MCCB's casing is made of mold insulating material, providing protection to the internal components and ensuring safe operation in various environments. MCCBs are available in various standard current ratings, typically ranging from 10A to several thousand amperes. The rating indicates the maximum continuous current the MCCB can carry without tripping. DB commonly refers to a distribution board or distribution panel. This is a crucial component in an electrical system that divides electrical power into subsidiary circuits, providing a way to distribute electricity around a building or facility safely and efficiently. It receives electrical power from the main supply source, such as the sub-main distribution board, SMDB. Distribution of electricity. The DB distributes electricity to different areas or sections within a building or facility through the subsidiary circuits. An ELCB, or Earth Leakage Circuit Breaker, is a type of safety device used in electrical installations to protect against electric shocks, electrical fires, and electrocution. It functions by quickly disconnecting the power supply when it detects a leakage of current to earth. An ELCB monitors the flow of electrical current in a circuit. If it detects an imbalance between the outgoing and incoming current, indicating a leakage to the ground, it quickly disconnects the circuit, thus preventing potential harm. ELCBs are available in different sensitivity ratings, usually ranging from 30 milliamps to 300 mA. The rating denotes the level of leakage current required to trip the ELCB. MCB stands for Miniature Circuit Breaker. It's a type of circuit protection device used in electrical systems to protect against overcurrent, short circuits, and electrical faults in domestic, commercial, and industrial applications. MCBs are designed to automatically interrupt the electrical circuit when an overload or overcurrent condition occurs. This protection prevents damage to electrical equipment and wiring due to excessive current flow. MCBs are available in various standard current ratings, commonly ranging from 1A to 125A. The rating indicates the maximum current the MCB can carry continuously without tripping under normal operating conditions. Loads in an electrical context refer to devices, equipment, or systems that consume electrical power from an electrical supply. These loads can be diverse and range from small household appliances to large industrial machinery. A capacitor bank refers to a grouping or assembly of multiple capacitors connected in parallel or series within an electrical system. The primary purpose of a capacitor bank is to improve power factor and provide reactive power support to the electrical grid. One of the primary purposes of a capacitor bank is to correct the power factor in electrical systems. Power factor correction involves adjusting the balance between real power used for useful work and reactive power used for magnetizing devices like motors. Capacitor banks, when strategically placed in electrical systems, provide reactive power, thus improving the power factor and making the system more efficient. Thank you for watching our videos. Subscribe to our channel for more videos.